Now let's look at the fifth and final type of reaction, redox reactions. Redox stands for reduction and oxidation. In these reactions, one substance is being reduced and the other is being oxidized. First, let's understand the meaning of these terms, oxidation and reduction. In simple terms, oxidation means addition of oxygen and reduction means addition of hydrogen. But there are other ways of defining oxidation and reduction. So let's go ahead and make a table of oxidation versus reduction. We just discussed the first difference. Oxidation is addition of oxygen and reduction is defined as addition of hydrogen. Oxidation can also be defined as removal of hydrogen and reduction is removal of oxygen. Now, oxidation need not be only addition of oxygen. We can expand the definition to addition of any non-metal or electronegative element. Similarly, reduction can be addition of a metal or electropositive element. Now we can define oxidation as removal of a metal or electropositive element, and similarly reduction is removal of a non-metal or electronegative element. Oxidation can also be defined as loss of electrons and reduction is gain of electrons. You can remember the last difference with the help of this simple mnemonic, oil rig. Oil stands for oxidation is loss of electrons and rig stands for reduction is gain of electrons. Let's look at some examples of redox reactions. Let's say we have copper oxide and hydrogen here, and when they react we get copper and water. Now if you look carefully, this is a displacement reaction because hydrogen is displacing copper from the compound copper oxide. Now let's take a look from the redox point of view. So if you look here, copper oxide is losing oxygen and becoming copper. So copper oxide is getting reduced here. And hydrogen is gaining oxygen and becoming water. So hydrogen is getting oxidized in this reaction. And remember, always the reactants get oxidized or reduced, not the products. In this reaction, hydrogen is helping copper oxide to get reduced to copper. So hydrogen is the reducing agent. And copper oxide is helping hydrogen get oxidized to water. So copper oxide is acting as the oxidizing agent. So remember, the substance that gets oxidized is the reducing agent and the substance that gets reduced is the oxidizing agent. Now let's take a look at some more examples of redox reactions. Let's say here we have copper and oxygen, and when they react we get copper oxide. Now who do you think is being oxidized and reduced here? Let's take a look. So if you look at copper, copper is changing to copper oxide. So oxygen is being added to copper. So copper is being oxidized here. Now what about oxygen? Since a metal is being added to it, oxygen is being reduced. So oxygen is our oxidizing agent and copper is the reducing agent in this redox reaction. Let's look at another example. Hydrogen sulfide and chlorine react to give hydrogen chloride and sulfur. Now who do you think is getting oxidized and reduced in this reaction? Remember, the answer to this question is only the reactants, not the products. So let's take a look at the reactants. So if we see hydrogen sulfide, it's changing to sulfur. Since hydrogen sulfide is losing hydrogen, so that's correct, it's getting oxidized. And if you look at chlorine, hydrogen is being added to it and it's becoming hydrogen chloride. So chlorine is being reduced here. Let's pin redox reaction on our concept board. Remember the key point, reduction and oxidation are both taking place. Friends, I hope the 5 important types of reactions are crystal clear to you now. So next time you see a chemical reaction, I would encourage you to fit it into one of these types, and that will help you predict the reaction. So you won't have to memorize all the reactions. And now are you ready for the top 3 questions on this topic? Try solving these questions and let me know your answers and doubts by putting it in the comments below. I promise to reply to all your comments as soon as possible. So I'm going to disappear and you pause the video here and give these questions a shot. I hope you found this video helpful and you have a better feel of the different types of chemical reactions.